Hey guys, what I want to do real quick is I just really quickly want to talk about what exactly blockchain is. I get so many questions from friends, family, people that don't really understand what it is that I do, and I really want to kind of make some distinctions here, kind of explain a little bit about the company that I work for, a little bit about what blockchain is, and a little bit about how all this stuff kind of coincides with one another. So let me take a quick 5 minutes of your day, and hopefully I can help you understand this concept. All right, so first things first, when we think of how do these pieces all fit together, right? So what I've done here is when we think about blockchain, most people are like, oh, well, that's Bitcoin, or that's this, or that's that. What I try to do is I try to kind of show the encapsulation of these various different pieces and how the pieces are kind of fit inside of each other, right? So I want to kind of go through this list and kind of explain what each one of these represent, right? So when we think about blockchain, that's what I work in. That's the industry that I work in. And it's, in essence, a new method for storing data. That's it, right? So when you think about how data has been stored traditionally we've stored it in what's called a CRUD database. That means it's create, read, update, and delete, right? So in a CRUD database, that means that I can create new values, I can read existing values, I can update existing values, and I can delete values. Now, in a distributed ledger, you just remove those last two pieces. There's no update and there's no delete, and there's only create and read. And so, in essence, you have the ability to track the history of all transactions in a distributed ledger. So, the beauty of this is even if something does change, you have the ability to track to see how it changed and who changed it. And so that's really important. And so we have the ability to ensure that we see the transparency in the entire transaction across the board. So when you think about exchanging data, exchanging value, exchanging things like this, you have the ability to see everything that happened there. So you know where your money went, you know where your value went, you know where the house was at, you know who owned the house. There's no discrepancies in land deeds and things like that. So that's what makes this really so cool. So anyway, I'm getting kind of carried away, but blockchain, again, is just a distributed ledger that's globally distributed, and it has built-in networking. And that built-in networking gives you the ability to kind of ensure that the new entries that are on the database are done correctly. So that's called consensus. So anyway, that's what that whole concept is. We do have what's called private, public, and hybrid flavors. That means that in a blockchain environment, what you have is you now have basically in a blockchain environment with private, in a private environment, you have a scenario where only the people that are part of the network that have been verified by the network have the ability to participate in the network of that blockchain. In a public network like Bitcoin and Ethereum, that means anyone that wants to be a miner can set up a rig and start mining and actually start being part of that network. Now, the difference is that one has some type trust kind of relationship built in and another one doesn't. So Hyperledger is more of a private type network, and then a public network would be more like Ethereum or Bitcoin. Okay, so that's the concept there. Hybrid is what we do at Dragon Chain. We give you the ability to have a private network of trusted consortia and then define that network internally on how you want to layer that out, and then we allow you then to put that information that you have in your private network onto a public network as an artifact, so then you can ensure the provenance of the data at that particular point in time. And that's really important because then you can ensure that that's what happened with a particular transaction and none of it has been modified or altered. And so that really helps to ensure provenance and things like that. Okay, so cryptocurrency. Let's talk about cryptocurrency. Everybody's all like, oh, Bitcoin, what is this? Listen, it's real simple. When you pay for something, you take a piece of value and you exchange the piece of value for something else of value, right? That's all you're doing. And so all we're doing is we're changing this to a digital method. The best analogy that I can make is like, when you initially got on the internet, I guarantee you one of the first things that you probably did is you set up an email account, and you had the ability to now exchange letters, or you had the ability to exchange correspondence electronically that could be viewed as a letter, as an email. And so you were exchanging your mail electronically instead of going snail mail down to the post office box. Well, now just imagine you're doing the same thing that you did with the post box with your wallet, right? So what you have in your back pocket that holds that value that you use to buy and purchase things, now you have the ability to exchange the value that you have in that wallet, or whatever way you store that value. You have the ability to exchange that digitally across the web, and you can trust the network to do that because of the technology that is defining it, because you have the ability to check the transaction all the way through and you can see what happened, right? So anyway, that gets into a lot more detail, but basically that's the concept. And so Bitcoin, Ethereum, Neo, these different platforms provide this functionality. Now, many times, and also Dragon Chain provides that functionality. Now, that's the company that I work for. So now, the other thing too that we want to understand here is that we also have a thing called tokenization. Now, this is where a lot of people are really kind of getting weirded out about this, because traditionally, if a company wanted to go public, right, if I wanted to get crowdfunding from the public and I wanted to start a corporation or start an entity that was going to provide some type of service, whether it be a restaurant or whatever business silo that I go into, when we do that, many times we have to take money out of our pocket. We got to get funding from a bank. We got to, something like that, right? So the SEC could then define, when you went public with your company, how you were going to fractionalize that company and then provide assets to whoever it was that invests in your company. And so that's basically that concept. And so what we have with tokenization is we have the ability to, in essence, create tokens that can then in turn provide value, whether that value be in the form of equity, whether it be in the form of utility by using a particular platform like what we do at Dragon Chain, or whether it be a security like what we were just saying with like the SEC. Maybe you have a company currently and you want to tokenize the company and then take it public through that method instead of going through the stock exchange. Then that's a security, right? And so anyway, that's the different methods. But in essence, it's your way to integrate the transaction, whatever that transaction should be, whether it be a transaction for exchanging supply chain information or whether it be a transaction for actually exchanging equity within the business. So that's why there's a lot of people who are curious on what type of token that you're dealing with. Is it a utility token? Is it an equity token? Is it a security token? These basically define the method that the token is being utilized for, right? So I can talk about that later. If you guys got questions about that, just ask me and I'll help you. But basically, I just wanted you to kind of understand that concept. So now, why is this so important, right? So this is really kind of the big deal here, right? Because everybody's so worried about their data and they're worried about hacking, right? Because right now what we have is we have kind of this centralized model, and a lot of people are moving to the cloud, and I want to talk about that here in a second. It'll be in my next slide. But before I do that, I want to kind of give you a history of programming languages, right? And so I'm not going to go all the way back to BASIC and stuff like that, but I want to talk from C up, right? So when we think about C, it's been around a long time. It's a very complex language to write code in. It was really designed to write standalone applications that would just run on one particular computer. And it really didn't have a whole lot of security concerns because it was designed that way to just run on one machine. It really didn't share a lot of data. And hacking was really pretty hard to do from within the actual C program, right? And so then we came up with like C#, right? So the C# programming language, it expanded on the C programming language, but when we got into C++, we started to use what's called object-oriented programming. It made things much easier for programmers to define objects and then use and instantiate those objects, declare variables and things like that, and so instant methods and all that kind of fun stuff. So it really kind of solidified how we should kind of write our code, and it also introduced some neat things like inheritance and encapsulation, which made the data that we're working with much easier to work with, right? So but the writing of the code itself is still pretty complex. It started to have a little bit of security concerns, but the hacking is still really pretty freaking hard, right? And so not a lot of the C# and the C++ applications get a lot of hacking. But then we introduced Java and .NET, and the purpose of these programs, was to make ease of the application building. You can build applications quickly and easily. It's very user friendly. It's very easy for the coder to write code and use these tools that have been very much simplified for them to be able to utilize. The problem with that is that now, because they're so simple to use, it now also invites in the hackers, right? And so the hacking is extremely possible, and it's very much available. Now, in that, many of our .NET apps and our Java apps are built today in centralized type models, and also in some of our cloud apps are built in Java and .NET and things like that. And I'm not saying that they're absolutely horrible, but they're vulnerable, right? There's certain vulnerabilities that need to be verified to ensure that that particular code is good to go, right? And so just as a general rule, they're just not necessarily as secure, right? And so in that centralized model, with using .NET and Java and web easy to build type applications that might have been homegrown and not necessarily tested and hardened and things like that, then that invites hackers, right? So that invites hackers to come in, and if you're in a centralized model, you have one place where you're storing all your information, like Equifax or Target, or all these various different spear phishing attacks that we see from the Russian government. Maybe it's Julian Assange, whoever it is, somebody's trying to steal your information, right? And so if you have a centralized model, you got one place to attack, and that's kind of a problem. Okay, so so when we think about that, that centralized model, right? So we want to take that centralized model and move it into a cloud data, right? We want to move it into cloud data. Now, when we move it into cloud data, we then need to kind of look at how that cloud data is being stored, and then also if that cloud data is going to be a central resource for somebody to actually hack into, especially if it's storing the data in what we call a CRUD database, right? And so CRUD, again, means that you can do creates, reads, like you can with a distributed ledger, but you can also do updates and deletes. And so if somebody can update something, they can change various different facts. They could change ownership of an object. So we don't want that when we're extracting value, right? We don't want them to change something, right? We have to be able to, if something changes, we have to see what it was before and what it is now. So we have to have what's called UTXO, or what came in and what came out. So we know how it changed and who changed it, and is that viable based on what's in our contract. So anyway, that's what that is. When we deal with a decentralized global distributed ledger, again, it is read and create, and that's really the only things you have. And so that gives you a little bit more control over the data, or at least the ability to see what happened with the data. Now, depending on how the smart contracts are written and how the distributed ledger network is set up, and how you define your levels of trust, which is what we do at Dragon Chain, excuse me, then you actually have a lot more control over this, and now you have the ability to plug in what do you need, right? And so this is why this is so important for businesses. And anyway, so this is it, man. People just have a hard time to wrap their head around this, because they think, oh, well, money's not going away. Well, no kidding, the money isn't going away. But just think about this for a second. I'm going to give you an analogy. Let's say that I own Tommy's hair salon right across the street, and I'm cutting hair, and I'm kicking ass cutting hair, and all of a sudden I run out of shampoo, right? So I run out of shampoo, and I'm just SOL because I don't have any shampoo. What if I had a device that was monitoring my shampoo dispenser in my salon that would automatically notify my supply chain vendor anytime that got below half, and I would automatically get a delivery within 3 hours? What if I could do that? I'm pretty sure I can do that. I'm almost positive I can do that. And I can also eliminate the supply chain in the middle. And that's pretty amazing, because we can tap all of this into suppliers and then just automate the process. And all you have to do is build the smart contracts around whatever vendors you're dealing with and plug that in through what's called a REST-based API. And if you're not familiar with that, that's the way that business exchange data right now currently, so they're really not changing much. All we're doing is providing transparency in the transaction. That shit's badass, man. If you don't understand what I'm talking about, and if this hasn't resonated with you, then please feel free to reach out to me, like I said. But one last thing that I kind of want to talk about is kind of some of the advantages of this. So when we think about global distribution, that means that we don't have to do all those backups anymore because everything's distributed globally. There's as many copies. I mean, last time I checked, there was 14,000 nodes mining Bitcoin, right? So you have 14,000 backups. I think that probably handles your disaster recovery. Dual entry accounting transactions are reconciled instantly. That's kind of what I was talking about with like inventory for the shampoo at my shop or whatever. Votes. You could track voting, immediately. So you could actually see, oh, wow, look, Donald Trump's winning the election. Get out there and vote, if that's not who you want to win. I don't think that's probably something that we would want to do because then, that could drive all kinds of weird stuff going on election night. But anyway, that gives you guys an idea of, real-time consolidation of data is pretty cool. So we don't have to wait to reconcile. No need for a middleman or some type of clearinghouse. Code is law. We don't need some supply chain company to coordinate all this stuff for us. We build it into our contract, set up the API, and that's it, man. That's now maybe the supply chain company helps us do that. Maybe that's their new business model. But hey, if you're the guy in the middle, then you just need to pivot. That's kind of the way I look at it. All right, so why blockchain? It tracks access, any access. Doesn't matter what asset it is. If you can represent an asset digitally, it can be tracked on the blockchain. Period. That's it. I don't care if it's your house. I don't care if it's your computer. I don't care if it's your car. I don't care if it's a vote. I don't care if it's a credit card. It doesn't matter. As long as you can track the asset digitally, you can put it on a blockchain solution. And that's really badass because what this does is now trust can be defined at your level, and then you have the ability to own your data, right? And so now you have that data on a blockchain. It's there. It's only one place, and anybody that accesses it has to come through you. Now, let's talk about individual sovereignty for a second. How many of you have had your password stolen, had your identity stolen, all these kinds of things? Or how about when you have to go to apply for an apartment and you got to show them how much money you make? Well, they don't need to know how much money you make. They just need to know that you make more than $30,000 a year or something stupid like that. So that's what I'm talking about here. Why can't we provide them with the information that they need based on data minimalization and still provide them the answers that they need, but not give them all of this excessive data that then allows them to mine that data out and sell it to other people? Because this is where our problem lies today in security, and this is where our problem lies in fraud and all of these problems that we're having across the world in fake news and all these different kinds of things. A lot of these things can be fixed based on provenance and ensuring factual data and having transparency in it. And that's the whole concept of this technology. So I really hope that you guys understand this. Man, I got off on a lot of tangents there, but I just want to kind of get you guys up to speed with that. Now, last thing here is licensing, and I want to talk about this because this is something that my company does, and we do a lot of cool shit. But this is something that we do specifically that I think is really important. In a traditional model, when you think of software, you think of, oh shit, I got to go buy a license, I got to go buy it, and it's going to cost me thousands of dollars, and I got to do all these things. No, okay. Traditionally, what you would do is you go buy Office, right? Office costs you $400 or $500, and then you could use it until the new version of Office came out, and then, oh wow, now you're screwed. You got to buy the new version, right? The stuff still works with your old stuff, but if you want the new features, you got to upgrade. Then they came out with the subscription model, right? So the subscription model, you got to go pay somebody every year. Every year, you got to give them this amount of money, and then you can't use the software unless you're paying your subscription. If you didn't pay your subscription, you can't get access to your data. That's crap, right? That's what happens with a lot of cloud-based systems today. So what about this? What about a tokenized micro license? Okay, let me explain this. Buy the token today, just like if you bought your software license. Instead of, let's say that $350 to buy Office gave you 1,000 usages of Office. Then every usage, it just ticked one off, right? And then you kept the same updated version, same updated everything, but then eventually you run out of tokens, you just buy more tokens, right? But you only pay the cost to you is based on when you made the purchase, not when the business decided on to do an upgrade to make more revenue or decided to release some new version so that they can increase profits. That's not what this is about. This is about protecting the consumer, right? And so you are now in control of your data. We're empowering you with this technology, man. And I hope people can start to understand this, because, man, this is going to change the world. I mean, if you've not heard it, it's the fourth industrial revolution. People are building the groundwork of this. It's just like the internet of the, I don't know, 1992 or something, you know. First time I got started involved in computing, we didn't even use TCP/IP. We used NetBEUI, you know, so that gives you kind of an idea what I'm talking. Anyway, I'm getting off on a tangent, but so as a wrap up, I just want to kind of just remind you guys, if you're watching this video, what is blockchain? It's our ability to fundamentally change the way that we're storing the data so that the data can't be hacked, so that the code is law, and we can take advantage of owning that data back, right? So that nobody else owns it. We can see it. We know who owns it. This thing eliminates things like denial of service attacks. It eliminates so much that we as a society have to be cognizant of this and pay attention. I hope this video has helped you. If you have questions about this tech, or if you want to come to one of my meetups or something, just hit me up on LinkedIn or Facebook or whatever. I'm gonna post this video out there for anybody that just wants to watch it. I hope I made you some really cool info, or I relayed some cool info to you. Cool. Have a great weekend. Later.